Okay, in question 6 we've got a question about a polynomial. Here it is. Okay, and in part A we've got the remainder theorem, and in part B we've got the factor theorem. Now these are trigger phrases. They mean that we're not going to be using the grid method, not yet. Okay, the remainder theorem and the factor theorem are both variants on what you may have heard me call in class the magic X method. Okay, so in part A I'm going to need to decide, I'm going to need to look at this divisor, and I'm going to decide what the magic X is going to equal. It makes this thing equal 0, and I'm going to work out the P of that X. In other words, I'm going to substitute that value of X in to this, and I'm going to get an answer, which I'm going to interpret to find the remainder. Okay, and then similarly in part B1 I've got a different divisor, so I'm going to have a different X value. I'm going to work out P of that X value. I'm going to get an answer. Okay, this is a show that question, so I need to end up with this. This is my end point. I need to end by saying whatever answer I've got for P of X, it needs to be able to justify me then saying X minus 2 is a factor of P of X, and I must end up by saying that. Now in part 2, I've got to write it as a product of linear factors. Okay, so X plus 2 is going to be one of those factors, and this is where you do use the grid method with X plus 2. Okay, just as it is in your notes, you're going to work out X plus 2 times a quadratic that you're going to get across the top, and then to get linear factors you're going to have to factorize that quadratic as well. Okay, then part C. The curve with equation y equals this. Oh look, this y is exactly the thing that we've already factorized. So having factorized it may well help. But in fact the first bit is just about finding the value of k. So this is much easier than it might look. Okay, when they say a point, okay, a point's got an x and a y. So they're giving you an x is 0, and they're saying, okay, so the y is k, find that k. So if I know that x is 0, how do I find y? Well, I've got an equation for y here. So that's how you're going to find the value of k, and it's very easy, which is why it's only worth 1 mark. Okay, and then I've got to sketch the graph of this, okay, indicating the values of x where the curve touches or crosses the x-axis. Okay, so touches means it does something like this. Well, except it actually does touch it, or this, okay? And we know that that happens when there's a repeated root, so maybe that's a hint that this should have a repeated root when you factorize it. I don't know. Okay, but hang on, let's get first things first. What do we do for a sketch graph? We think about the y-intercept, we think about the x-intercepts. Before either of those things, we think about the shape. Okay, so this has got x cubed, so think about that leading term and think about what that tells you about the probable shape. Okay, the x-intercept and the y-intercept and the x-intercept. Well, for the y-intercept you're going to take x to equal something. For the x-intercept, y has got to equal a particular number, so you're going to be solving a particular equation involving this y, but you've already factorized it into linear factors, so that will help. If there's a repeated root of that equation, you've got a clue about the kind of thing that might be going on. Okay, and there'll definitely be one the root that isn't repeated, so that'll be an ordinary root where it does this or this. Okay, and join everything up. Make sure you label everything, preferably on the graph itself. Draw a nice big clear picture and you should be all right.